Rumors circulating across social media platforms have created a wave of confusion and fear, with many users claiming that a massive comet is on a collision course with Earth. These claims have spread quickly, often without verification, and have led to heated debates and widespread anxiety online. The comet in question, referred to as 3I/Atlas, was detected by NASA's Atlas telescope on July 1st, and ever since, online discussions have inflated its significance far beyond what scientists have actually said. Some users have begun describing the comet as a major threat to humanity, even suggesting that the global scientific community is downplaying its potential danger. Others have taken a more speculative angle, debating how such a comet could be diverted from Earth if it were truly headed toward us. These conversations range from amateur theories to highly imaginative scenarios that resemble science fiction more than scientific reality. A number of posts have even gone so far as to describe supposed military movements and international coordination efforts meant to counter the comet before it impacts Earth. These claims, lacking credible sources, have nonetheless amplified public alarm. The rumors gained additional momentum after the New York Post published an article on September 29th with a dramatic headline suggesting that the comet was larger than previously thought and could even be alien technology. Headlines like these, designed to attract clicks and provoke curiosity, often condense complex scientific statements into sensational phrases. As the story spread across social media, users posted screenshots and quoted lines from the article to support their claims that something extraordinary and dangerous was approaching Earth. One user on X, under the name Stephen Greenstreet, contributed to the frenzy by writing, "Scientists say a massive alien spaceship is hurtling towards Earth. Why aren't more people talking about this?" Even though this was not a scientific consensus and lacked factual grounding, the phrasing fueled imaginations and encouraged others to repeat the claim as though it were credible. Meanwhile, another account, this one using the name Richard Roper, expressed concern by stating that a massive comet was reportedly speeding toward Earth at 130,000 miles per hour. He asked whether it could be stopped and referenced being told about 2 missions in the works, one involving a specially selected Messiah crew and another involving 2 squads, echoing plot lines from popular disaster films rather than anything documented within real space agencies. As these posts spread, they tapped into a familiar pattern in online culture, the blending of scientific discovery with speculation, fear, and entertainment. Social media thrives on dramatic narratives, and astronomical events are often transformed into viral sensations that bear little resemblance to the measured tone of actual scientific communication. Many people who encounter these stories do not have access to the scientific background needed to differentiate between credible reports and imaginative exaggerations. Consequently, statements framed with confidence, even when unsupported by evidence, can exert a powerful influence. In this case, the lack of immediate context around the discovery of Comet 3I/Atlas created a vacuum that rumors easily filled. While NASA and other scientific institutions release information through official channels, their explanations tend to be technical, careful, and precise, qualities that do not spread as rapidly as sensational posts or alarming headlines. Another factor contributing to the rapid spread of such rumors is the public fascination with catastrophic space scenarios. Movies, TV shows, and novels have ingrained in popular culture the idea that Earth could someday face an existential threat from a comet or asteroid. These fictional narratives often follow a familiar template. Scientists detect an object on a collision course with Earth, governments scramble to respond, and heroic missions are launched to save humanity. When real-life astronomy reports mention a newly detected comet, people sometimes instinctively frame the event through this cinematic lens. This makes it easier for exaggerated claims to appear plausible, especially when paired with statements implying secrecy or international cooperation behind closed doors. The human mind tends to fill gaps with imaginative interpretations, particularly when dealing with unfamiliar scientific information. The rumors about Comet 3I/Atlas also highlight the role of misinformation in shaping public perception. As soon as social media users began treating the comet as a threat, Others joined in to speculate about potential defense strategies. Some posts suggested that governments were mobilizing military units to prepare for an impact. Others claimed that special task forces or secretive global alliances were meeting to plan a response. None of these claims were supported by credible evidence, but their dramatic tone appealed to audiences who were already intrigued or fearful. The suggestion of secrecy added an extra layer of urgency, giving people the impression that something was being hidden from them. In the modern online environment, misinformation spreads quickly because it is designed to provoke immediate emotional reactions: fear, excitement, outrage, or curiosity, long before users take time to verify facts. In reality, scientific organizations such as NASA, ESA, and other space agencies consistently monitor comets, asteroids, and interstellar objects. Their findings are published openly and reviewed by experts in the field. If an object truly posed a risk to Earth, there would be transparent communication through official channels. Scientists use precise mathematical models to calculate the trajectories of celestial objects, and these calculations allow them to make accurate predictions about the likelihood of impact. When new objects like 3I/Atlas are detected, the initial data often contains uncertainties, but these uncertainties are a normal part of the process and do not indicate hidden danger. Over time, as more observations are gathered, the object's path becomes clearer. Public fear often arises during the early phase, when information is still incomplete. But scientists emphasize that initial uncertainties should not be misinterpreted as signs of impending disaster. The uproar surrounding 3I/Atlas demonstrates how easily scientific discoveries can be misinterpreted when removed from their proper context. Sensationalism transforms neutral information into a source of alarm, and social media accelerates the spread of such distortions. Many users share posts reflexively, without verifying the source or understanding the underlying science. Some share because they are genuinely concerned, while others do so for entertainment or engagement. In both cases, the effect is the same: a rapid amplification of inaccurate narratives. Once a rumor becomes widespread, it can be difficult to correct, even when scientists and fact-checkers attempt to clarify the truth. Human psychology tends to hold onto dramatic possibilities more tightly than mundane explanations. The conversation around this comet has also sparked discussions about humanity's preparedness for potential space threats. People debate hypothetical scenarios involving engines large enough to nudge a comet's trajectory, nuclear devices designed to fragment space objects, or robotic probes capable of pushing an object off course. Although such technologies are discussed in academic research and long-term planning, they are far from the dramatic, last-minute rescue missions depicted in movies. Real-world planetary defense efforts focus primarily on early detection, careful tracking, and strategies that rely on small, gradual adjustments rather than explosive interventions. Nevertheless, online discussions often ignore these practical details, opting instead for speculative ideas that sound more thrilling. In the end, the rumors about 3I/Atlas reveal more about human behavior and the nature of digital communication than about the comet itself. They show how quickly information can become distorted and how difficult it can be for factual scientific communication to compete with sensational narratives. While scientific institutions continue to provide transparent and accurate information, individuals must also learn to approach extraordinary claims with caution, especially when those claims originate from unverified or sensationalized sources. The fascination with cosmic threats is understandable, but it is essential to distinguish between fiction and reality in order to maintain a reasonable perspective. For now, the comet remains an interesting astronomical discovery rather than a threat, and the dramatic stories circulating online serve primarily as a reminder of the power and the pitfalls of modern social media.